This video is about special sequences, and we can see that by looking at the first two terms. The difference here is 0, and the difference here is 1. The difference here is 1 again. And the difference here is 2. The difference here is 3. The difference here is 5, and it gets a little bit confusing, right? Because this sequence is exactly the same as the one above. So we would just get this recurring sequence if we kept finding the differences between them. And instead what we have to do is to think about what we're doing every time. And if we're just adding 0 here and adding 1 here, really what we're doing is we're adding the previous term. So to get to this number 2, we had to add these two together. So we add the 1 and the 1 together, and that gives you the 2. But then to get the next term, you'd be looking at these two terms, adding them together to get the 3, and so on. So I'm going to just erase all of that because it's getting a bit messy. So then you can see here to get the 8 would have been adding the 3 and the 5 together to get the 8, and so on. So what about then the next term? So that would be 8 plus 13. And the 8 plus 13, that would be 21. So if this term here is the 21, to find the next term would be adding the 13 and the 21 together, which would be 34. This is called the Fibonacci sequence. And you'll see this cropping up a lot in nature. So if you look at the distance between, let's say you've got a point here, and you take the distance 1 and then 1, and as we go clockwise 90 degrees, we'll make the radius the next number. So the next radius would be 2, the next radius could be 3, the next radius would be 5, the next radius would be 8, the next radius would be 13, and so on. And we just join them up. We'll get this sort of spiral pattern. And this is very commonly seen in nature. You'll see these on pine cones, on sunflower seeds, even typhoons. So you'll see this everywhere in nature. And there's something called the golden ratio, which is the ratio between any term and the term before it. And if you keep going with this sequence and you go to the 1000th term, and you look at the 999th term, and you look at the ratio between these, it gets closer and closer and closer to this golden ratio, which is called phi. And that's quite an interesting thing, because this number here is what makes things look pleasant. It's aesthetic. So if you look at, let's say you call this length 1, and you call this length, this number, which is phi, then this rectangle is called a golden rectangle. It just looks very pleasant. And you'll see this in good looking faces. You'll see this relationship all over the place, and it's quite an interesting part of maths. But now to find a formula for calculating this nth term, if I wanted to work out what these terms would be, I need to find a formula to do that. And instead of the conventional way that we've been doing before, we can look at we look at the u formula instead. So the nth term would be the term before it, which is un minus 1, and then you add the term before that, which is un minus 2. Now this is a formula for calculating the nth term, but do you see a problem with this? If I wanted to try to find the 1000th and 999th term, I wouldn't just be able to go ahead straight away and do it, because I don't know what the terms are before it. So this is a formula for finding it, but it hasn't quite helped us to find these two terms. So that's something to investigate.